Assalamualaikum and hello everyone. We are from Group 6. We'll present to you about the industry case study, construction of a snack factory over deep soft soil deposit at kawasan industri Kendal, Semarang, Central Java, Indonesia. So, this is our group member, which is Faris, Darshini, Kirtana and Jocelyn. For this project, it requires the ground improvement method, which is the ground improvement is to improve the engineering properties of the soil, which is treated to meet the project performance requirements. For this project, it has been conducted on Semarang in Indonesia, which the owner has proposed to build a factory, office and warehouse. The problem with this project is the location of the project is covered with the soft soil more than 20 meter deep, so it will not suitable for the pile foundation to be used in the area. And soft soil characteristic may influence the project during or after the construction phase because the good bearing layer for pile foundation has not been found on that area. So our objective is to identify and analyze the suitable method of ground improvement in that area, and we need to propose the detailed field implementation of that method. And this is the soil profile that we get from the soil data, and it shows that the area has covered with the soft clay soil for more than over 20 meter deep.
I'm going to present about the vacuum preloading. Vacuum preloading method is a method that uses atmospheric pressure as a surcharge to improve soil characteristics. It involves a drainage system, sealing or isolation system, and vacuum pumps. This method can be conducted by applying a vacuum suction into an isolated soil mass to reduce the atmospheric pressure and pour water pressure in the soil and resulting in soil consolidation and effective stress enhancement without changing the total stress.
For step 1, prepare a working platform for equipment to safely access the job site. It is then followed by installation of prefabricated vertical drains and horizontal drains network within the target improvement area. For step 2, place a 30 to 50 cm thick sand layer on top of the PVD and horizontal drains network. Place geotextile on top of the sand layer. Finally, cover the whole target improved area with geomembrane as presented. The sand layer of geotextile function as a protective layer to protect the geomembrane against puncture by any leftover sharp roots or stone. Step 3. Connect the HDPE pipes placed underneath the sealing system are connected to the vacuum pump by flexible pipes. For the steps 4, the vacuum pump is then started to pump out water from within the improved zone and vacuum pressure is monitored and maintained around 80 kPa whenever necessary. To further accelerate the concentration process, water that comes out sometimes is pumped back and pulled top of the improved area act as surcharge. For step 1, prepare a working
Soil improvement method. We produce both the prefabricated vertical drain material and the prefabricated horizontal drainage material, commonly known as the PVD method, which is used to enhance soft ground. Now that the standard PVD technique no longer requires a significant amount of natural sand for the sand blanket or soil for preloading. Our prefabricated vertical drain method may enhance soft ground even in those situations. As a result, not only is the cost, sand and soil minimizing decrease, but so in the environmental stress is causes inefficient. We strive to further minimize environmental stress in the soft ground improvement by employing biodegradable material for the prefabricated vertical drain material and prefabricated horizontal drainage material. Well, now, our group idea and innovation to achieve our objectives and for the ground improvement is using biodegradable plastic instead of PVD in vacuum preloading method. Biodegradable plastic is eco-friendly for soft ground improvement, which well reproduce the physical advantages of prefabricated vertical drain. It is also biologically degraded after installation and ground consolidation in natural soil condition without leaving any residual plastic behind. Bio-prefabricated vertical drain is the first prefabricated vertical drain that obtained Eco label from the Ministry of Environment of Korea.
Next, I will explain about advantage biodegradable plastic. There are 5 points, which are the cost of producing biodegradable polymer is higher, but at the end is worth. Second, depending on the substance used, 2. Manufacturing the bioplastic and disposal technique. Biodegradable plastic only degrade over 3 months. Third, product made of biodegradable plastic are little more in tune with nature. Not only that, the plastic may be easily recycled using organic method, required less than degrade down when thrown than other variety. Last is the soil can become fertile by composing bioplastic product improvement soil fertility. For the advantage of biodegradable plastic, they have 5 points, which are biodegradable plastic are produced from plants like corn and soybean. As a result, there is possibility of contaminant since the crop and frequently treated like a parasite while within ground, and because they are easily transferred to incorporate in a finished product. Next, the requirement of expensive industry process and compressor is drawn back of the biodegradable plastic, especially of the material that must be broke down at the higher industry temperature. In addition to the price, there is a requirement for equipment ability which might be issued. That bioplastic should not be combined with plastic that would biodegrade, because it is impossible to determine if crop used to make this polymer were exposed to in this dangerous substance. Next, since cornstarch is one of the main ingredients in the item made for the biodegradable plastic, the biodegradable plastic must be decomposed properly and quickly. This implies that rain may speed up the deterioration. Last is biodegradable polymer may disintegrate incredibly quickly and even with less effort.
Now, I would like to explain about the bearing capacity calculation. In our project, we used the Degassis method to find out the bearing capacity values, and the value that we chose was 5.7 for NC, 1.0 for NQ, and also NY is 0.0. This is because the soil that we used in our project was the soft soil clay, and the bearing capacity value for 4.0 and 4.5 depth is already existed the load above the original ground, which is 7.0. This is why we need the ground improvement method. Next, I would like to explain about the settlement analysis. In our project, the total value of the effective overburden and the assumed value is already higher than the pre-consolidation pressure. Thus, we assume that the soft clay in our project is over-consolidated. Thus, the ground improvement method is required to make the improvement in the ground. So in our project, we used the case 1, and the settlement value that we get was 3.208 millimeter.
Effort. In the conclusion, the best and the most effective method that we choose as a ground improvement method in our project for the industrial area Kendal Semarang, Central Java, Indonesia is vacuum preloading. Before choosing the method, we need to look into 3M, which are money, manpower, and machinery. For having a great improvement, it requires cost-effective solution for soil with a low strength and treatment to make them suitable for construction.